Morning everyone. Today my topic is around drive mechanisms and flow regimes. Myself, M.J.A from Amet University in Department of Petroleum Engineering. So let us go into the topic of drive mechanisms and flow regimes. First of all, we would like to start with this topic where exactly it will come in petroleum engineering. Under petroleum engineering, we have different disciplines. It starts from exploration. Next, discovery. Next, delineation. Next, production. And abandonment. So, these are the stages that we start about exploring a petroleum reserve. First of all, we'll start with exploration and then discovery, delineation, production, abandonment. Let us briefly discuss about all these stages. Exploration means you are trying to go in a search of crude oil. Where exactly the subsurface crude oil is that we are going to search for that. That stage involves an exploration. In this particular department, we are having so many types like geophysical exploration, geological exploration, and seismics. So these are different disciplines involved in exploring crude oil. Each discipline has its own importance for finding the crude oil. Once after finding a crude oil presence in particular area, you need to find out through some certainty parameters to discover the reservoir. So the reservoir can be exploited or not. It can be discovered by this particular stage. Appraisal, everything will be done in this particular stage. Means that after getting one's confidence that there is a chance of crude oil presence over there, then the stage we will be naming it as discovery. After that, we will go for delineation. Delineation means it is the finding the limits of a particular pool. So when we have found out a crude oil reservoir, then you need to limit the overall extent of that particular crude oil. Beyond the crude oil, what is there? Up to which extent crude oil have been extended, that setting of limits we will be naming it as delineation method. And after that, it will come to production level. So production means once after delineation, that means you have discovered the crude oil and the pool limits have been delineated. And after that, you need to start producing crude oil from that particular subsurface. In this production literally means like producing crude oil. In this particular stage, we have three stages. One is primary, secondary, and tertiary. Primary stage, secondary stage, and tertiary. Primary means briefly, if you have to discuss about primary means, once after drilling a well, the oil will start to flow itself into the production well. That by itself, when it is flowing, the name we name it as primary recovery mechanism. And the drives which were acting towards that particular production, that we will be naming it as drive mechanisms, which we are going to discuss briefly in our concept. And second one is secondary stage. Once after natural production of total crude oil by itself, then we will go for secondary production. During secondary production, we are going to introduce water. Water is an incombustible fluid which will act in such a way that it can push crude oil towards production well from an injection well. So in that way, you can able to produce more amount of crude oil by this water flooding. That particular stage we will be naming it as secondary. And finally, tertiary. Tertiary means after natural production of crude oil by itself through reservoir drive mechanisms, and after that by water flooding, and finally when these two procedures have been finished, some amount of crude oil will be left. That oil we will be naming it as residual crude oil. This particular residual crude oil cannot come with water or by nature itself. So you have to apply some artificial techniques which were human made, which we have to consider by ourselves technically. Then we have to apply it so that this particular residual oil can be agitated and it can be produced from that particular reservoir. This extent of production will be a little bit less compared to primary and secondary production. So this is how total production will be taken. Primarily, different drive mechanisms will be there. This is about today's topic. And second will be water flooding. Third one will be enhanced oil recovery. There is two difference between tertiary recovery and enhanced oil recovery. First of all, tertiary by name itself says after secondary. Enhanced oil recovery means that doesn't mean that it has to be after secondary recovery. This was given 2 decades back that the terminology happened to change for this tertiary recovery to be enhanced oil recovery because today's complexity in this reservoir is we cannot be able to find fluid oil in the natural productions. So in that case, even sometimes they may feel water flooding also. So in that case, after primary production, if you apply in case of water flooding any other technique that can be named as enhanced oil recovery. If not, in secondary, if you apply primary stage itself also we can name it as enhanced oil recovery. In this particular enhanced oil recovery, we are having different techniques. One is like chemical, thermal, gas injection, and microbial. So this is overall production of petroleum from exploration to production. After complete production stage, we will be going for the maintenance. So complete production has been ceased down, then you have to close the well with proper completion techniques. So let us go with our topic, drive mechanisms. So when we talk about drive mechanisms, first of all we need to understand that this particular concept will be seen during production stage. So we are having different drive mechanism techniques. First one is depletion drive. Second one is gas cap. Third one is water drive. Fourth one is gravity drive. Fifth one is combination drive. So there are 5 types of drive mechanisms we encountered during primary production stage. First one is depletion drive, gas drive, water drive, gravity drive, and combination drive. See, let us start with depletion drive. First one, depletion drive. Before going into depletion drive, let us start from the basic concepts of crude oil production. First of all, crude oil will be generated at source one, that is considered to be shale. Source one considered to be shale. These symbols are geological symbols for shale. After that, once crude oil has been generated in shale, then it will be migrated to, or else it will be expelled to a reservoir which is having porous areas. So that is sandstone. So once the crude oil has been generated from shale, it will be migrated to sandstone. There itself it will not get trapped. It needs the surface or else it needs an impermeable zone to trap this particular crude oil. So crude oil once after getting into sandstone, it will start to dry the crude oil towards some particular extent. Initially, before crude oil entering into sandstone, the porous layers inside sandstone will be filled by water. Once the crude oil starts to drain from this, the water will dry crude oil towards such extent where it will be trapped to some particular place where shale will be a impermeable zone. towards some particular area where there is an anticline structure or else low pressure zone will be there here, so that the crude oil will be trapped into this particular zone and top crude oil cannot escape. Why? Because it was trapped by a sea, which the lithological formation of sea is also shared, where there is no permeable zone over it, so that it will be trapped here below the water will be there. So oil has been trapped. This particular zone is known as reservoir. So the top one is cap rock, and the lower part is source rock. Source rock may be nearby or maybe at generation is source rock. So source rock, reservoir rock, and cap rocks. So these are the main structure of reservoir system. Top, the zone is cap rock, which is impermeable, which will not allow any fluid to bypass through it. Below that one is reservoir, where it will hold crude oil, gas, and water. And below that one, source rock will be there. So source rock where the oil gets generated and it will be migrated to reservoir. So this crude oil will be compressed with water and gas. So it will be in the form of compressed state. So let us talk about once during exploration stage, if they find a reservoir which is having crude oil, then from surface they will start drilling the well directly towards this particular crude oil zone, which is a reservoir. So once after drilling this particular well, once you perforate it, if you open the well, then crude oil starts to get filled by itself. Why? Because crude oil will come from low pressure, high pressure to low pressure zone. So here the reservoir pressure will be very high. So here the pressure will be near to surface pressure. So with this pressure difference, oil will start to flow with the help of drilling fluids which is present inside the drilling pipe. So let us talk about depletion drive mechanism. Depletion means pressure reduction. First of all, why we name it as depletion drive? Once the crude oil starts to flow from this particular reservoir to surface, the pressure from reservoir itself will starts to get reduced. Actually, crude oil which is present inside the reservoir, it is not crude oil by itself. Inside crude oil, some amount of gas will be soluble inside. That soluble gas will be named as solution gas. We name that gas as solution gas. This gas is not equivalent to the gas which is above crude oil. The above crude oil gas we name it as free gas. This is free gas. So the solution gas, which will not look like a gas, it will be looking in the form of crude oil. It is like solution, which was mixed inside this particular crude oil with high pressure. So once the oil starts to enter into this production well, pressure will starts to get reduced. During pressure reduction, the gas as a solution form which is inside crude oil will start to get expanded. So while in this expansion method, the crude oil will be driven towards this particular production well. So this is like driving. So that means like when pressure is reduced, the solution which is present inside the crude oil will start to get expanded. So while in the process of expansion itself, it will drive more amount of crude oil towards this particular drilling perforations, nearby drilling perforations. So that it will drive. The expansion of gas itself will make crude oil to drive towards the well. So while expanding itself, the drive mechanisms will act oil to push towards a production well. So there is a limit for all expansion. So once after complete expansion have been finished, that solution gas will start to get escape from crude oil. So this particular stage we name it as saturated stage, where the pressure we name it as bubble point pressure. So bubble point pressure means like first escape of first bubble. The escape of first bubble at a particular pressure we name it as bubble point pressure. So when pressure is getting reduced and reduced, there will be a stage where the gas from the solution gas will start to get escaped from the system. So that particular pressure we name it as bubble point pressure and saturation stage. So this is about depletion. Depletion means pressure reduction makes solution gas which is present inside crude oil to get expanded. So while in this expansion process itself, you will get crude oil push towards production well. So this is the topic of depletion well. Next one is gas cap. Gas cap means already the free gas which is present above crude oil will pressurize oil to go towards the production well. Here there is a small criteria you have to consider. If gas starts to get produced before oil, then the pressure which is pushing oil towards production well will start to get reduced. That means you need to save this particular gas energy to make it as a drive mechanism. It's not like the gas will always tend to see a place where it can enter into the perforations. So in that case, what you have to do is you need to avoid gas coming into perforation. So you need to keep gas at above gas oil point, so that oil will be get pressurized by gas and it will be pushed by towards production. So this is what exactly we will talk about gas gap then. So gas gap is not equivalent to solution gas. Solution gas is the gas which is present inside the crude oil. But gas gap is above that one, which will act as a drive mechanism which will push it so that the oil will be produced from this production well. After gas gap, let us talk about water drive mechanism. Water drive. Water drive mechanisms. Water is an incomplete fluid by nature. So it will never mix with crude oil, which is below the oil zone. So once the oil starts producing inside this crude oil, this oil water contact will raise it. The amount of porous zone which have been created, much amount of porosity by oil which is entering into the production zone, that porous layers will be filled by water and it will start to rise up and it will pressurize much amount of crude oil to go into this product, to make oil to go into this perforations. So oil from lower edge will start to pressure oil towards up so that the oil will start to go into perforations. That is water drive. And the fourth one is gravity drive. The name itself says gravity drive. Gravity drive is as per the gravity of these three solutions, the settlement of these three fluids will be taking place. It's like the less gravity solution is gas, which will be settled at the top of the oil, and the highest gravity solution is water, complete oil. So it will be settled at top. While settling water down and gas up, that makes crude oil to push it by itself. When it is settling down and gas is going up itself, will make pure crude oil, which will be tended to go towards your production. And finally, combination drive. Combination drive is, by name itself we can say it's the combination of any drive mechanisms which we have mentioned before. Either water drive, gas drive by itself, or else depletion gravity by itself, or else depletion water, gas drive by itself, or else combination of all. Any combination of property of any kind of gas or any kind of drive mechanisms which we apply. At a time, water and gas can act. At a time, gravity, water, depletion drive can act. So this is the combination of all drive mechanisms, either 2 or 3, any combination. More than 2, you can take it as combination drive mechanisms. So out of all these drive mechanisms, the contribution of crude oil from reservoir will be much like water drive mechanisms. Since water is not dissolved inside crude oil, which acts like an incompressible fluid, it will contribute much amount of reservoir pressure to push oil towards the production well. The production may carry up to 75% of OIP. OIP means original oil release. So the oil which is present inside the reservoir, we name it as original oil release. The total production by water mechanism will be up to 75% of total saturation of crude oil. Remaining oil will come next to water drive mechanisms. So this is exactly about drive mechanisms. Let us talk about flow regimes. Let us discuss about flow regimes. Flow regimes are of 3 types. First one is steady state flow. Second one is pseudo steady. Third one is unsteady. Steady state flow, pseudo steady, and unsteady. We will be observing this particular flow regimes during production process. Once after drilling a new well, either an exploratory well or else injection well or development well, any kind of well, where there is a crude oil, when you are drilling towards that particular crude oil zone, then initially after drilling that well, crude oil will be in rest stage. That will be like you are disturbing crude oil by drilling a well up to that particular reservoir. When you close the well and if you drill it up to the reservoir zone, then crude oil, the properties of reservoir, nothing will be changed. Once after perforating and allowing crude oil to come into production, then the properties inside the reservoir will start to get affected. So that means like in a reservoir, for understanding this steady state flow, these types of flow equation, we need to see from top view and bottom view. That is like, imagine this is a reservoir. It is like a top view. So if you have drilled a well, so when you drill a well, before production, imagine that the reservoir pressure is around 2000 psi. So the surface, the pressure will be nearly surface pressure. It will be nearly 14.7 psi. So you have drilled up to the depth of a particular target where the pressure is around 2000 psi. Once after perforating this particular well, then crude oil, wherever you measure before, crude oil which is entering into production well, everywhere it will be same. PR is equal to 2000 psi. So oil starts to come into production well. So here the pressure disturbance will be created. That is like when reservoir pressure is at static, that means at 2000 psi, the flow of oil will not be seen. But once the perforation starts to get open, then the pressure will start to get reduced. Why? Because this is exposed to surface pressure and drilling fluid will be above here. So 10 psi difference. It's like 90 psi will be inside and 2000 will be outside. Makes crude oil to come into your production. That means here it is 2000 psi and below this particular alignment it is 1990 psi. So there is a difference. Makes crude oil to come into this particular. This will continue for some time, and after that, this pressure will start to get reduced to 1990 psi. At T1, it is 2000 psi. At T2, it will be 1990. So after T3, this 1990 become 1980, and the other zone will be at T3 zone it will be 1990. And beyond that, it will be 2000. And next to that one will be when time goes on. Imagine if you take time difference between 1 hour to 1 hour. So T1 to T2 is 1 hour, T2 to T3 is 1 hour. So at each hour, you will be seeing pressure reduction. So the pressure reduction will make crude oil to come, which will make crude oil to go into your production. So after T3, the pressure disturbance will go like this. So T4. So at T4 it will be 1990, T3 it will be 1980, T2 it will be 1970, and at T1 it will be 1960. So the pressure disturbance starts to travel from the wellbore to external bore. It will take from particular time. So the time which has taken pressure disturbance to start moving from wellbore to external bore, we name it as transient time. This particular time we name it as transient time. And this time, during this time, the oil will start to get produced. And the production of crude oil, if you measure at T1, T2, T3, wherever you measure, the flow rate of that particular crude oil will be constant. Flow rate will be measured by BPL per it will be like volume per time. So crude oil will be measured in barrels, that is BPL, and the time we are making it for 1 hour, so that at each hour, how much amount of crude oil which is produced, that will be constant. So these two stages reflects unsteady state flow. That means if you measure pressure, pressure is not constant anyway. So pressure, if you take a location here, let us take this location as I. At this location, after some time, the time is when you change the time, the pressure is also changing. At T1, here it is 2000 psi. At T2, it is 1990 psi. At T3, it will be 1980 psi. Means that when you change location, the time is when you change time. When you change location, the pressure is changing. At the same time, when you change time also, the pressure is changing. Means that pressure is a function of location and time. Means like you measure pressure at any place, pressure will not be constant. Here, if you take location here, it will be 1990. Here, if you take it, it will be 1980. Here, it will be 1960. So when you change location, the pressure will change. At the same time, keep location constant and change time. When you change time, like T1, the pressure is 2000. At T2, it will be 1990. T3, it will be 1980. So when you change time, the pressure is changing. When you change location also, the pressure is changing. That means pressure acts like a function of location and time. So that we can name it as the change in pressure with respect to time is dependent on location and time, which reflects steady state flow. So this flow will be encountered immediately after drilling a new well. So once you drill a new well, the pressure disturbance starts to get created and it will start to move towards external boundaries. During this particular stage, means during the time taken by pressure disturbance to meet external boundaries, the flow regime we name it as unsteady state flow. The next comes once the pressure disturbance reaches to external boundary. Once the pressure disturbance reaches to external boundary, that means the final pressure disturbance the pressure disturbance started at one bone and it slowly expanded, it has reached to boundary. That means like before this disturbance reaches to this boundary, the boundary pressure will be 2000 psi. So it will be affected by this particular disturbance. Like 2000 psi will be there, this will be 1990 and 1990, 1980. Like that, it will come here to 1960. So the flow will happen from 2000 psi to 1960. The oil will start to move like this. Why? Because high pressure to low pressure. It will move from external boundary to low pressure. So when these pressures were capacities, if it is constant, if they are not changing with respect to time, means that if you measure pressure at T1, this is the stage. When you measure pressure at T2 also, if it is not reducing, then we name this particular regime as steady state flow. Steady state flow means like the pressure at external boundary is 2000 psi, the pressure at wellbore is 1960, which is not reducing at any time. At T1, 1960, at T2 also 1960, T3 also 1960. At any time, if you measure it, wellbore pressure will be equal to 1960. So at any time, if you see this particular condition, the flow rate you can observe to be constant. The flow rate also, how much amount of crude oil which you are producing at that particular time will be constant. And this particular system, we will be naming it as steady state flow. Here, flow rate will be constant. Again, unsteady state also flow rate will be constant. And the condition for this one is changing pressure with the changing time is equal to 0. Why? Because the pressure is not changing at any time it was given. So that represents it is dou P by dou T is equal to, since P is constant, dou P by dou T is equal to 0. So this stage is a very saturated stage. It will take very less time. After going from steady state to super steady, this the time taken for this particular stage will be very good. So this will continue up to some extent. After that, the pressure at wellbore to extend voltage will start to get reduced, meaning constant. Means at T1 it is 1960 to 2000, but T2, when it comes to T2, this 1960 will be dropped to 1950, 1980 will be dropped to 1970, 1990 will be dropped to 1980, 2000 will be dropped to 1990. So, constant drop in pressure reduction you can observe at T. So, when you are changing time with respect to hours, first hour you will be observing at 1950, second hour you will be getting 1940, third hour you will be getting 1930. So, like that, it's no reduction, like constant reduction. At every time, the time taken to reduce will be, it will not take 10 ps. So when you are changing from time T1 to T2, the reduction in pressure you can observe it as 10 ps. So the constant reduction of pressure is like the reduction in pressure is constant. That means dou P by dou T, the reduction of pressure at different times is constant. That is constant. At the same time, flow rate also will be reduced constantly. So these are the three flow regimes you will be observing. How much time will be taken to produce these semi-steady state? That means like super steady will be taken for much amount of crude oil to be produced. Then the highest amount you can observe it as unsteady state flow, and finally it will be steady state flow. Steady state flow duration is very much low, and pseudo steady state flow duration is very much low, and unsteady state flow is in between steady and pseudo steady. So these are the conditions. For steady state flow, the condition is dou P by dou T is equal to 0. For pseudo steady state flow, the condition is dou P by dou T is equal to constant. And unsteady state flow, the condition is dou P by dou T is equal to, it's a function of location and time. So these are the three types of flow regimes which you will be encountered once you start drilling in a particular production. Once after drilling it, you will be experiencing with unsteady state flow. After that will be the first one. Second one will be steady state flow. Third one will be semi-steady or pseudo steady state flow. Thank you for listening to this concepts and giving me the opportunity. I will thank you for